If we request for LED on, the LED is on, and if we request for LED off, the LED is off. Hello everyone, welcome to Electronics Workshop. This is our third video in our IoT series. In this video, we are going to see how we can send data from any web browser to NodeMCU server and perform the tasks accordingly. For doing this project, we must have better concept about client and server. A client is a computer hardware device or software that assists a service made available by a server. And server is a physical computer dedicated to run service to solve the need of the other computers. In very simple word, client is a device that requests for data, and server is a program running in any hardware which can respond to the requested data. For example, when we open our Chrome from laptop and type gmail.com, our laptop is a client requesting data for gmail.com. Similarly, the response for gmail.com is stored in Gmail server. When any client types gmail.com, they will get this interface, which is the response to the requested data stored in a Gmail server. The full documentation of the project is provided in my website www.electronicsworkshop.com. The URL of the documentation is in description box. Once you click on the URL, you will get this interface. Before going to the coding section, you must be familiar with some of the important terms used in the programming. Here in this project, we are going to see communication between client and server. So we must define both in our program. We must make one variable client using the command Wi-Fi client and another variable server using the command Wi-Fi server. We can make any variable like client 1, client 2 or server 1, server 2 as per our requirement. The port 80 is used because port 80 is a port where server listens to. So server always reads the data available at port 80. Server.begin is important function which is described in a setup section of our programming that helps us to start our NodeMCU as a server. ReadString is another important function in our programming section which helps us to read the string value being sent by a client. It reads the value until the terminator arrives. For example, in this section, we have created a string variable request which stores all the value being sent by a client until next line arrives because we have used /n as our terminator. Another important function is request.trim. This function is used to remove the garbage value present in request function, readString function. Another important function is request.trim. This function is used to remove the garbage value present in readString function. Now we are going to see how we can read the data that is being requested by a client to a server. For that, you can just go to my website and copy the code server reading a data from a client and paste it in your Arduino IDE. These codes are used for Wi-Fi connectivity, which I have already described in my previous video. In this section, you must place your SSID of your Wi-Fi network, and in this section, you must place the password of your Wi-Fi network. We must create one variable client which is defined as Wi-Fi client and another variable server which is defined as a Wi-Fi server. Coming to the setup section, these all line of code are used for Wi-Fi connectivity that is also described in my previous video. If you have not watched that video, you will get his link in description box. You must first watch that video how we can connect our NodeMCU to Wi-Fi. Server.begin function helps to start our NodeMCU as a server. Coming to the void loop, this function server.available helps to know whether client is requesting a data to server or not. When our client is requesting any data, its value is equal to 1 and it will go in this loop. This function read string function helps to read the string value that is being requested by a client and store that value in request, which is of string type. This function helps to print the requested value in our serial monitor. And finally, request.trim helps to trim all the garbage value that is present in readString function. So, I think we all are very much clear with our programming section. I think we are very much clear about our programming section. Now, let us upload the code in our NodeMCU board and see the output in serial monitor. Go to tools and select the port. Our port is selected. Our board is also selected. Now upload the code. Once your code is uploaded, open your serial monitor. If you cannot see anything in your serial monitor, then just press reset button of your NodeMCU. Then you will get the IP address of your NodeMCU. Just copy your IP address and paste it in any web browser that you are using. After pasting it, write the message that you want to request for. Suppose if I write hello and press enter, you must receive same message in your serial monitor. Yes, I am getting the same message hello in my serial monitor. And if I change the message, how are you, then I must receive the same message how are you in my serial monitor. See, I am getting the message how are you in my serial monitor. So we have successfully started our NodeMCU as a server, and the data requested by the client is being read by our server, that is NodeMCU. Now we will do a small modification in our code where we on and off our LED. The main aim of this project is if the client requests LED on, then LED must be on, and if the client requests LED off, then LED must be off. For that, we must know what data we will receive in a server if we request LED on and LED off from our client. If we request for LED on, then we'll receive this message, this data in our server side. And if we request for LED off, we'll receive this data in our server side. So now by using these two data, we can on and off our LED. So let's go to our programming section. We have connected our LED to pin number D2 of our NodeMCU. So Here in setup section we write pin mode D2 as output. Coming to the loop section, if we receive this data in our server, then our LED must be on. So I'll copy this data. If request equals to that value, then our LED must be on. Then digital write D2 must be high. Now I'll copy this, Ctrl C, I'll paste it over here, and if I get this data, then our LED must be off. I'll copy this and I'll paste it over here. And I'll make this high to low. We have completed our programming section. Now we'll see the output. You can upload the code and see the output. You can upload the code in your NodeMCU and see the output. You can get this code in my website URL also. Now let us upload the code and see the output. Select the port I have already selected and select the board that also I have already selected. Now upload the code. Once our code is uploaded, we'll see the output. The connection diagram is very much simple. We have just connected the positive terminal of our LED to pin number D2 of our NodeMCU and negative terminal to ground. If we request for LED on, the LED is on, and if we request for LED off, the LED is off.